Hello students, in this class of ours we are going to see how different elements react with each other, and we know that some of the elements are highly reactive and others are not highly reactive, moderately reactive, and yet others do not react. So right at outset let me tell you about the elements which are highly unreactive, or they are called inert or noble gases. So to mention them, see, we have helium, we have neon, we have argon, we have krypton, we have xenon, and we have radon. This is Xe, radon. These are the elements, and they are called noble gases, or they are called inert gases, and both the names are given to these elements because they are highly unreactive. There is no tendency on the part of these elements to react. And chemical reactions that we are talking about. So this was all about the noble gases. Noble gases, these are noble gases, and they are called noble or inert gas or noble gases because they do not react. They have no tendency to react with other elements. And why this tendency is not there? Because their outermost orbits. In case of helium, it is the first orbit. In case of neon, there are 2 orbits, and the second one is having 8. And in this, there are 3 orbits. The third one is having 8, 4 orbits. Fourth is having 8, and this is 5 orbits it has, and fifth is having 8, and this is having 6th orbits, and the 6 orbits and 6th one is having 8. So this configuration on experiment, it has been found that these gases are highly unreactive. And if any other element, we want to see that any element wants to be stable, unreactive means stable, they don't want to react, that means they are stable. If some other elements also want to become stable, in this universe everything wants to become more stable. So for doing that, the tendency on the part will be having to gain the electronic configuration of these elements, the noble gases. This is having 2, so let us say the outermost orbit will have 2. This is having atomic number as 10, so this will have 2 and 8. This is having 18, 2, 8 and 8. This is having 36, 2, 8, 18 and 8. This is having 54. Atomic number is 54. Electronic configuration is 2, 8, 18, 18 and 8. And this is having 86, 2, 8, 18, 32, 18 and 8. So we can see all these elements, it is this way, are having, this is in second 8 elements, then third orbit 8, fourth orbit, fifth orbit 8, and sixth orbit 8. So their outermost orbit is having 8 electrons, and this is having only 1 orbit, and the first orbit at the most can have 2 electrons. 2 are already there. So we say that the outermost orbits are completely filled. And during a chemical reaction, it are only the electrons that are present in the outermost orbit of an element, the rearrangement of those electrons takes place. And here the rearrangement means some of the elements will lose the electrons, and undoubtedly these are metals. Non-metals will gain the electrons, and when it is between a non-metal and non-metal, then the sharing of electrons will take place, and metals do not react. So with this we will see that if on experiment they are found to be very, very stable. Now if other elements also want to become stable, so these elements will try to have the electronic configuration of the noble gases. If noble gases are unreactive, if noble gases are inert, or they are not reactive, then if another element wants to become stable like them, that has to get the electronic configuration of the noble gas. So for this, we will be talking how chemical reaction takes place. So there are certain bonds, we call chemical bonds or simply bonds. These are nothing but the force of attraction, or the force that establishes or that holds together or that links in a molecule. Either it links atom, or it links ion and ion. That in depth we will see. Right now let us go on to what the ions are and how the electropositive ions are formed. So I will talk about sodium first. The atomic number is 11. Atomic number is 11, and electronic configuration 2 is 8, 1. Now this wants to gain the same configuration as that of a noble gas. So what it will do, it will lose one electron. There are two chances that it can gain 7 and make 8 in third, and it can lose 1 and make 8 in second. So because of energy considerations that we are going to see in the higher classes, it is not possible for sodium to gain 7 and make 8 in third. It will lose 1 and make 8 in second. So this electronic configuration will become like this. See, in this condition, atomic number 11 means protons are 11. And if 11 protons are there and one proton is having 1 unit charge, 11 electrons are there and 1 electron is having 1 negative unit charge, so overall charge will be 0. Now if you see, so Na281, and it happens to lose 1 electron, so this will become Na2 and 8. Protons can neither be lost nor be gained, so again 11, but here it has already lost 1 electron, so electrons are 10, so overall charge is 1, so this will gain plus 1 charge, and so this is called positive ion, electropositive ion. It is having 1 charge because it has lost 1 electron. That charge can be seen from here. Now another element we will see is magnesium. If I have magnesium, its atomic number is 12, its electronic configuration is 282. Now again, if it wants to have the same noble gas configuration, so what it will do, either it can gain 6 and make 8 in third, or else it can lose, but because of energy consideration, this is not possible for magnesium atom to gain 6, it will lose 2. And here plus 12 minus 12, overall charge 0. Now if I write magnesium here and 2, 8 and 2, and I say minus 2 electrons, so this will become magnesium and 2 and 8. So electrons are still 12, but sorry, protons are still 12 and electrons are now 10, so plus 2, so this will develop 2 plus charge. So this is an ion of magnesium. Similarly, you can see aluminium, if we refer, it is atomic number is 13, 2, 8 and 3, and if it happens to, see, let me make plus 13 minus 13, overall charge is 0. Now if I write here aluminium minus 3 electrons, if it happens to lose 2, 8 and 3, it happens to lose 3, it will become aluminium 2 and 8. Now protons are still 13, but electrons are 10, so plus 3, so this will develop 3 plus charge. So this is an ion. Ion, by definition, ions are the atoms with charge, or charged atoms are called ions. So they are developing charge, all the 3 of them metals, and metals are bound to lose electrons, and any metal it is, in the outermost orbit it will have either 1, 2 or 3 electrons, and because of energy considerations it cannot gain 7, 6 and 5. Instead of that it will lose 1, 2 and 3, and by that it will become electropositive ion. This is sodium is monovalent, this is divalent, and aluminum is trivalent, and the positive ions are called cations. Rest we will see in the next class.